Good morning, Kmart shoppers. Welcome to another edition of Gecko Math. This is Gecko Math 1.2. If you were supposed to be doing a different Gecko Math number, then you're on the wrong one, but obviously you're in the right place. I'll quit talking and let's just get business. Today, we are going to identify how powers describe repeated multiplication. Powers and repeated multiplication. Those are a couple of concepts you need to remember. All right, we've got a few words worth knowing today. There are 3 to be exact. First, we've got a power, okay? A power looks like this. All right, a power looks exactly like that. We've got a number and then this little number up in the corner by it. And a lot of people think, oh, that's easy. That means 5 times 4. That actually is not correct. That's not how a power works. I'll explain how it works in a moment. When you say this, you don't say 5, 4. You'd say 5 to the 4th power. Okay? Another one is a base. Okay? A base is a number. Like I showed you an example, that's 5. A base is the factor that you use or a factor that you will multiply inside of a power. I've got my base, and then you've got an exponent. The exponent, there's my base. The exponent is this little number right here. The exponent is the number that tells me how many times I'll be multiplying my base that's inside of a power. So in this case, I'm going to multiply the number 5 4 times. So in other words, I'm going to say 5 times 5 times 5 times 5. 5 to the 4th power. So again, let me back up. I've got my little number that I add to it. That's my exponent, and together my power. Okay, so on this one, how would you say it? Well, I couldn't hear you, but I'm going to presume you got it right. It's 5 to the 3rd power. All right? I've got my base number, my factor, and then I've got my exponent, my number that tells me how many times I'm going to repeat that multiplication. So, does this mean 5 times 3? No, it does not. It means I need to repeat 5 3 times. 5 times 5 times 5. All right? And if you figure the answer to that out, it should be... Still waiting for the answer. Can you speak up? I can't hear. Just kidding. I think, 125? Does that sound right? Anyone? Fry? Okay, here's some examples that we look at. Now I've got 13 times 13 times 13. We can see that my base 13 has been repeated 4 times. Okay, so I would write this as a power 13 to the 4th power. I can even use this with variables too. I've got n times n times n times n times n times n. That's a lot of n's, but n can also be my base, and I've got it 6 times, and there's my exponent, so n to the 6th power. What does n stand for? Well, you can evaluate that variable later. We don't have to do that right now. I've got another example for you. So now we've got 12 to the 2nd power. I would write that as 12 times 12, and you would know that answer to be 144. And now we've got 1 2/10 to the 2nd power. Well, let's see. If I multiply that out, it gives me 4. 2 times 1 is 2. Carry my 0 down. Let's see, 1 times 2 is 2, 1 times 1 is 1. Bring it down, I've got 4, 4, 1. Now, if you forgot how to do these, you count up the number of decimal places there are. There's 2 of them. And then you'll move your decimal place over 1, 2, and insert it right there. So you've got 1 44/100. There's your answer. I've got 2 problems that I'd like you to try. These are your extra credit problems. These are the two that you need to have done when you show up to class on Thursday. We've got 6/10 to the fourth power, and we've got 10 to the fifth power. Just complete these on a piece of paper, show up in class, and we will rock and roll. Good luck, have a great day, and we'll see you tomorrow.